That's fine. I think that's okay.
Talk tomorrow? Or just the quiz. Oh, okay. What do you have left? Do you have the practice thing on Friday? And is there a test tomorrow? Okay. Okay. Fine.
Oh.
Get ready for beyond.
Like, look at it. What can you do?
I don't want to like.
Yeah, well, going like if this is actually I won't sign.
Oh, we do want money.
All right. Okay, hey everyone. What I want to do today is clean up my STR a little bit. After that, I want to do an example with blocks and arrays of STRs because that would be helpful with the assignment. And then if there's time, we're going to switch to a new topic. We'll see how that goes. So, okay. So last time we ended on trying to run valgrind on the thing. It's actually like I didn't do anything wrong. I just needed to like refresh the page. It works now. So essentially what you do is you go to the run valgrind submission thing. Okay, this is just valgrind, like there's no personal information there. So here I'll try to upload my things. So I want my str.h and let me just open those so that they're in the recent files. So just upload all of those. So I select, or you can drag them into the submission on the submit valgrind thing. I can then run them. And I will be using valgrind on my local machine. It's just that you can't. So just kind of the ones I want to show. So here it's going to say that there is a memory leak, which is kind of not the worst, not the worst thing. So here says the memory is lost here, and it actually was able to say, well, like you didn't free the thing when you were doing create string. All right. So I would go back to my str. Test my str. And you'll see, okay, so I did create the string, but it's true, I've never actually freed the either the memory block or the string that I created, right? So that means, hi everyone, how's the quiz? So was it no? I don't know. Anyway, so okay. Okay, let's see if anybody else shows up. Hello. All right, so what I was showing people is just the code from last time. So my str, my strc, my strh, test my str. Exactly what I did last time, except now it works. So all I needed to do was refresh. It was working. So if you want to run valgrind, again, just go to submit valgrind. So just select all the files in the program, upload, and it'll give you the output of valgrind running on Gradescope. All right. So, okay. So here we see that it detected a memory leak, so lost whatever, like all this stuff. And the reason that happened is that it's true. So in test mystring.c, I created the string. So that actually had two mallocs inside it, if you remember, right? So in create string, we malloc the structure itself. And then inside the structure, we also malloc the block. So you don't free it. That's a memory leak. So that kind of means that it would be good to have a destroy string kind of thing here. So just add it here. So do I need a double pointer or a single pointer here? So I wrote a single pointer. Is that okay? Who says it's not okay? Nobody. Okay. Yeah. What's your objection? It does. And but there is only one, so there's not a block here, right? So we're pointing to a my string. We're not pointing to the block. Yeah, but that's good though, right? So what do we need to do here? We need to basically say, we'll free the block, which we can access via PS, and then we'll free PS. So the difference I want to emphasize is that here it had to be star star. The reason it had to be star star, at least the way we designed it, is I want to be able to say create string and then set PS to be the address of the new struct that I created, right? So if I start with PS, which is nothing, I want to be able to send in its address so that this guy becomes a valid pointer. So if it starts out being a pointer, then it's got to be that I'm sending in the address of it. So it's got to be that create needs the star star. But destroy doesn't. Destroy doesn't need to modify the value of PS. It just needs to free it. So that's fine. Like you might argue that like if create is star star, why not make destroy star star? And that would be a valid argument as well. It's like a matter of aesthetics, like which one you prefer. So let's go with this. So I'll just implement destroy string. So that would be in my str. So I have my create string. So what am I going to do in destroy string? So if the string has been created, that must mean that, at least by this design, that the block has definitely been allocated. So I need to free the block. So I'll say free PS block. And I'll free PS. The order here is important. Because you cannot access PS block after PS has been freed. So free block first, and now can free PS. Make sense? Yeah. Well, it's not exactly that. It's so the block. So if you just free PS, what that means is you used to have your str, which is this guy, and now you basically don't know where the block is. It's still there. You just aren't necessarily able to access the address where the block is. Well, not so much that. It's that like you want to free both of them. So what I was saying is that if you free this guy first, then you cannot access the value PS block. So the block is still there. It's not freed, but you don't know where it is. Yeah. Yeah.
That's exactly. Yes, it is pointing on my screen.
Yeah, so if you remember, the way we allocated it is over here, right? So over here, we said, so we sent in the address of PS, and we set the value at that address to whatever malloc returns. So think about line 16 as undoing line 23. Right. So, just to remind you, so the way we called create string was create string address of PS, right? So over here, star P underscore S is the same as saying PS. So here we're saying allocate it, meaning allocate enough memory to be able to store this guy. And now we're saying we're done with it, so we're freeing that that chunk of memory. Right? Yeah.
So if we do valgrind or like test valgrind with gradescope,
Yeah.
which file would we
All of them. So like so kind of the way we're running valgrind locally is we're giving it the program. The way we're doing it in Gradescope is you're sending in everything that's required for the program to be compiled and run.
to upload 3 files at once?
Yeah. Or kind of for the assignment actually more, because you also need the inputs. Right? Because like Gradescope doesn't have anything. Like the run valgrind thing, it doesn't have anything, right? It's empty initially. You're sending in everything that, so kind of the way it's set up in the background is I just set it up to like run GCC and then run the program that GCC created using valgrind. Yeah. That's right. Okay. In fact, like so the question was kind of freeing. So let's do it kind of in here. So there is a distinction, right? So if you say like something like this, whatever, just very quickly. So S is still the same, right? So you're not freeing S if you're doing something like this. What you're doing is you're saying S used to be a valid address of the thing that malloc returned. And now it's not a valid address anymore because you freed the block of memory. So S is still that address. It's just not a valid address anymore. So you're not freeing you're not freeing S here in a way. You're freeing the block where S is the first element. Right? Okay. So that's like that. So now that we've defined the thing in mystrh and mystrc, we can say destroy str. We call it destroy string with it. So destroy string. And we'll say ps. Something like this. So I can now run it. Okay. And here it printed, and I can also try running valgrind on test mystr. So that's the name of the file. So if I've run it using the run button, it's there. And here you see that now there are no problems. Right? So just for the sake of it, let's say that I got confused and I did this out of order. So it might crash, or let's see if it crashes. If it doesn't crash, then we'll get valgrind to catch it. It did crash. So the reason it crashed is I freed PS, so I'm not allowed to access the contents at PS anymore. Yeah. That is undefined behavior. It's going to be less spectacular if I just comment it out. So this is still a memory leak because I'm freeing PS, but I'm not freeing PS block, right? So that's going to run, but I'm going to be able to catch it with valgrind. Yeah, I know, by the way, that VS Code broke on ECF. I was fighting with it yesterday to no apparent success. I'll try to fix it, but just use the laptop, I guess, for now. However, this does work on ECF, right? So the debugging doesn't work, but if you press the run button, it wouldn't run but you can run with valgrind, or you can run the thing like this. Okay. So wait, so let me rerun this. Okay. That's actually interesting. It did not catch the fact that they did not free block. So again, kind of not foolproof. Yes, you are supposed to free PS block as well. Okay. Again, can't even rehearse it because it's not like it doesn't always behave consistently. Okay, all right. So I want to kind of fix this up so that it's usable. So we basically wrote like the least amount of functions possible for it to make sense. So we have the set car, which I'll test in a second. I also want a get car, just because if there is a set car, like what's the point of having a set car if there's no get car? So I'll find a get car, and that will just be at index. So this is kind of getting the character at the index. The way I printed the string before was kind of not nice, because the way I printed it is I accessed the block directly. So usually what's nice is to be able to have different implementations. So in principle, to be able to say, I want to define the thing completely differently and not have to rely on knowing that, for example, the string is stored in block and not something else. So in order to avoid having to access block directly, I'll also define like get str. So that would be my str ps. Like so. I'll my str without the underscore. I'll copy get car and get str to my str.c, and I'll implement them. So get str, straightforward, right? So sorry, get car. So here I want to check whether the index is valid. So I'll say if the index is smaller than 0 or the index is greater than PS size, greater or equal. So again, I just want to crash. So I'll say and I'll exit. Get str will just return PS block. So that's the character. So now I can go to test my str and do whatever. So we'll do like so we'll append like eng, and then we'll append psi. So this is now like eng psi, and we'll like set character. So here I'll say like PS at 1, set it to n or something. And here now I don't have to rely on PS block. Instead, I'll get str. Yes. And I'll say get str PS here. and I'll print it again. So that's supposed to be like ENG psi. Get str. So in my str, I said this is void. This should actually be car star. And this should actually also be car star. So I can now run it. And here, apparently, we have a problem. So it didn't crash, but it did say index 1 out of bounds. So that suggests that I did not update size or something. Let me see. So here, over here, and indeed, for some reason, size here is 0, even though it's supposed to be 6. So that probably means that in append string, I did not do anything. So Control C to restart. I'll put a breakpoint on append string. And I'll debug. So I'll step in. And here I'll keep track of what's PS. So PS, currently it seems like the block does start with null, so that's good. Capacity is 100, size is currently 0. And here what happened is I did not resize, and when I did not resize, it's true PS as Z was not updated. Right, so here I'm about to strcat, so I'm about to copy, so that's going to be fine. So the block now starts with E. I can, if I like. Oh, it's PS. I'll do PS block 0. They'll move this a little bit so that you can see. So that's E. And I can do PS block 1. So that's going to be the small n and so on. So that's working, right? But the problem is as Z was not updated. So I just need to move this line over here. So that unconditionally, when I do strcat, the size actually gets updated. So, okay, let's try this again. Remove the breakpoint. Okay. So here, kind of, hopefully you see kind of what the design is, right? So I'm trying to make it so, and this is the same in project 1, right? So and the same in the lab that you've done this week. So I'm trying to make it so that inside the main function, I can just use my new string thing, which enables me to do strcat without worrying about reallocating. And I want to be able to make it mutable. So I want to be able to say like set car to whatever and have it just work without worrying about memory allocation or anything like that. Does that make sense? Right. Questions about this? All right. Who does not have it working on their computer? Why not? Why not?
I don't know, it prints off a bunch of really weird characters.
All right. Did it used to work?
No, they did this the other day.
Okay.
Prints off like a question mark inside of a diamond.
Yeah, I hate it when it happens. So question mark inside of a diamond would be just a character that, so like you saw, like, you know, like every character has the ASCII code. So this is some kind of ASCII code that's usually out of range. So what you probably want to do is make sure that you start out with the empty string. Right. So when we create it, so make sure that this actually happens. So in create string here, we are setting this to null. Yeah. All right. Okay. Yeah. Other questions? Yeah. Why? Oh, why this? Well, because when I create the string, it needs to be something, and the something I chose it to be a string of length 0. A string of length 0 is still a string. It's just that the first character is null. You try to print it, it's supposed to print just nothing. Make sense? All right. Okay. So this is this. Okay, all right. So I want to talk a little bit about abstract data types. So thanks to Francois for the slides. So what we've done just now is an example of it. And this is something that we'll be doing for a while now. So an abstract data type is basically any collection of values together with operations. So we saw those in Python a lot. So we had ints. So the ints have those kinds of operations associated with them, right? You have stuff like lists in Python. So we did a list in the lab. We just did a string. And the operations, thank you. And the operations that might be associated with the list are like stuff like insert an element at a certain index, remove from a certain index, get an element at a certain index, stuff like that. So the ADT specifies what the operations do on the values that are supposed to be in the ADT. The ADT does not generally specify how, right? So if you are using a list in Python, you're not worried about how it works under the hood, right? The whole idea is you know that you can append to a list, you know that you can get an element at any index of the list. You're not worried about the underlying algorithm. And in fact, you can swap out different algorithms. So the idea is exactly what we've been going for here is you want modularity. So you want to be able to just say, I'm using this implementation of the ADT, which has this and that property. And you want to be able to reuse. So the idea is that once I've written, for example, my str and my str.h, I can just compile them together with any kind of code that needs this kind of string, and it's all fine. So this is kind of terminology. I don't really care about like the exact distinction, but ordinarily what you would say is like a data structure would be an implementation of an abstract data structure, right? So abstract data structure is just like those kinds of values, and we have those kinds of operations on them. And then a data structure means this specific implementation that allows me to, for example, do something like this, or to, for example, do something like this. So the first example that you've already done in the lab of an abstract data structure is a list. And you can get more operations as well, but you have, So kind of just as an example of how you would define it. So you could say, what is a list? Well, it's a collection of elements that's ordered, meaning that unlike a set, you know where everything is. And you want to be able to insert at a particular index, you want to remove from a particular index, and you want to get the element at a particular index. So that's defined abstractly. There is multiple ways of doing it. So one of the ways to do it, you did in the lab this week, right? So I'm going to start now talking about another way of doing it. Sorry, so questions about this? So like all those slides are saying is an ADT is something like, well, a list, but I'm not going to tell you how I'm implementing it, or an integer, but I'm not going to tell you how to implement it. And it's like both data and then also operations on that data. Yeah.
Data structure is just a specific implementation of a type of thing.
Yeah. Again, like this is kind of vague. People use data structure to mean ADT as well sometimes, but yeah. But like if you want to make a distinction between ADT and I'm not going to ask you about like philosophical definitions, but yeah, like if you want to make a distinction between ADT and data structure, yeah, that's the distinction. Is it just is it the implementation, or is it just kind of the specification, right? You need to think about the stakeholders. Okay. Does that make sense? Okay. So, all right. So let's talk about implementing a list. So we had get, and we had insert, and we had remove. All right. So what are the considerations in terms of how to implement it? Well, you might say kind of, there's like speed, complexity, there is space. It's not an anything file, it's English. You're right, like don't need hashtag. So there's kind of speed and complexity, there is space. You might imagine kind of like ease of implementation, ease of use as well, I guess, right? Stuff like this. So what we've implemented so far, so you haven't implemented insert and remove, but we'll kind of just, or I think you have implemented one of them, right? You implemented remove. So what are the considerations there? Well, like if you have a list, and the way you store it is as a block of memory, what's the complexity of remove? Anyone? Yeah. So it's O of n, where n is the size of the list, right? Because in the worst case, remove element at I equals 0, need to move all the elements one space to the left. Does that make sense? Now, are you with me? Yeah. And you used kind of M move for that. Right. So, okay. So what about the space? Yeah, like n times size of int. Okay. What about complexity of inserts? So if I want to insert at index I. Or maybe there is a suggestion for O of I. Is that always true? So first of all, I think it's kind of never true, but I think you mean O of n minus I, right? Because need to move n minus I elements.
I think the program is to first count the I element and then.
Well, you don't need to count. So we'll get to that by I, because you don't need to like count off like how do I get to the 12? You can just say, you know, the address of the first plus 4. Yeah.
Why is so that minus I?
Well, I mean, like, so it is O of n. I was just riffing off the answer. So is it? Well, so the argument would be need to move n minus I elements to the right. But really it's O of n might need to move the entire block. Does that make sense? What's the complexity of get? So if I store it as in block memory, yeah. Oh, no, that's too much. Yeah, it is O of 1. Yeah. So why is it O of 1? Yeah, exactly. So you just get it, meaning need to compute the location of element at index I. And you do this using pointer plus so 1 addition, 1 multiplication. So all of that is O of 1. Sorry, it's green for no good reason. It's probably easier. Okay, does that kind of make sense for the kind of thing that we were doing in the lab? And there's like ways to fix it, but that's basically what it is, right? So this kind of motivates us to say, okay, like, could you do better? So could you make something that works faster, at least for some use cases? And the answer is yes. So I'll start implementing that. So what I want to be able to do is implement a linked list. A linked list looks kind of like this. So if the list is it will be stored as something like this. So I'll have like the data and I'll have like a pointer to next. And I'll have an address. So if this is like this, and I'll copy it a couple times. So here, we'll just make it be 2000. So those numbers are made up. So what I'll do is I'll store the data here as 5. And then I'll say, I want the next to be something like this. So like 3000. And then at 3000, I'll store the next data point. So that would be 10. And maybe the next I want to store at 2000. And then this one, I'll store the data as 2. Don't really want to store those guys. And then the next I'll store as null. So that's the idea. So somewhere in memory, I store 5, 10, 2 like this. So I store the data 5, and then I store where it would be that I'm storing the next element. So in this case, I've decided that I'm storing the next element at 3000, and the data for that is here. And then the next would be, why did I say? Oh, sorry. This is 2000 and this is data. And then for 2000, the next is null and the data is 2 somewhere there as well. Right? So I'm storing in those blocks. So the way I would represent it is something like this. Sorry, just remove the spaces so that we can see everything together. So I'm storing it as what's called this kind of linked list, meaning I'm storing 5 and 5 is connected to the 10 and 10 is connected to the 2. Yeah.
How do we know to start at 1020 there, and how do we know to go to 1000?
Right. So we will say that the linked list starts at linked list starts at 2000. Sorry, not 2000, actually 1000. Okay. And then the rule would be linked list ends at the node where next is null. Okay, so we'll define those as nodes. So this was kind of like the low level implementation. Right. So each of those guys, we call it a node and we'll store it, using a struct. And then we'll hook them up. Yeah.
Sorry, so if it starts at 1000,
yeah,
1000 tells you to go to 3000.
Yeah.
3000 tells you to go to 3000.
Yeah.
Tells you
that's the end. Yeah.
It never actually tells you nothing.
No, it does, because so those things go together. So because they're stored in structs. So you know that if you want to look at where the next is, it's right at that address. And if you want the data, well, that's like skip 20.
Okay, so the code knows to.
Right, because they're structs, yeah.
Node is struct.
Each node is a struct, yeah. So I was trying to like go, maybe that wasn't the best way. I was trying to go from, okay, like this is the implementation at the very low level, and now we'll implement it with a struct, yeah.
They know that it's any kind of node.
Well, I mean, you could say that. I was more thinking about, okay, like this is what it would look like on the computer. One digit at a time. Okay. All right. Okay. So this is this. I don't think we have really time to start implementing it. I do want to show you instead a list of strings, which I haven't done before. So we'll come back to implementing the linked list tomorrow. For now, I want to show you a block of strings, which might actually be more useful anyways. So I can say, sorry, so coming back, I'm doing a block of strings. So how would I do it? So I cannot really do this. The reason I cannot really do this so I can like manually go and fix it up, but by default, right, if I do just this, then I'm not properly creating each of the MySTRs here, right? So what that means is that ordinarily what I would do is something like this. And because like we're creating using pointers, we might as well do it like this. So str block. Right? So now what I can do is I can and then set str block 1 to be a valid pointer and so on. So this would be create. So create takes a pointer, sorry, the address of a pointer. Right? And that would be like this. So the way I'm thinking about it is I want an array of those kinds of things. So if I want an array of those kinds of things, that means that I need to malloc, for example, 40 of those kinds of variables. The address of the first element there would be my str star star. So that's why it's my str star star over here. And then this just falls out of it because it's of type my str star star. And then if I want something that's, so the way to think about it is if I want something that's equivalent to my str yes, I want to say str block a tie. So that's, if it's a tie, it's one element. So str block a tie is going to be of this type. And then if I'm creating the string, I want to say address of. Yeah.
You've just done STR block plus I.
Yes, I could have done str block plus I. Yeah. But that's just the same. Yeah. What so what we're doing is we want 40 of those kinds of values, 40 PSs. Right? So we want 40 of a pointer. No, they point to a my string. Initially, they don't point to, they're not valid addresses. We are calling create string in order to make str block at 0, str block at 1, and so on be valid addresses. That's right. That's right. That's right. All right. I will see you tomorrow. Bye. Okay.